I'm not embarrassed. I think I've been saying things well, so I'm not ashamed of what I've said so far. The surface of the Earth is flat. The surface of the Earth is flat. The surface of the Earth is flat. So I concede that if you're doing triangulation to figure out your distance to the ground position, the measurement of an elevation angle with a flat baseline, 90 degrees to the GP to the star, using 90 degrees at your position, that is only possible if the Earth is flat. The surface of the Earth is flat. Yes, you are measuring a flat Earth if you're doing a 90-degree flat baseline to the ground position. The only way that that would work is if the Earth is flat.
We are measuring a flat Earth, Matthew.
Yes, you are measuring a flat Earth if you're doing a 90-degree flat baseline to the ground position. The only way that that would work is if the Earth is flat.
Okay. Oh, fair enough.
Well, 10th might not be here, but Matthew Learns is in, I think.
Oh, really? Hello, Matthew.
Hello.
Have they fired you yet?
They have not. No.
Oh, jolly good. I'm sure you're elated. Any evidence of a physical geometric sphere edge? That's a horizon formerly known as Earth curvature.
So there's no evidence for that, no.
Any evidence you can acquire an elevation angle measurement from a curved baseline?
What say you, Matthew?
You could use the 90 degrees from Plum instead.
And where it
So
meets
not
the
baseline,
ground
then.
position, would that be 90 degrees also?
Yes, it would.
So that's flat Earth then. Did you hear me?
Yes, you're talking about if you're using triangles for celestial navigation?
Triangulation. So 90 degrees at the GP of the star, and you're saying you can get the angle from Plum 90 degrees at your position. So
Right.
90 degrees at your position and 90 degrees at the ground position of the star. Second time's the charm. That's a flat Earth, Matthew.
If the direction of down is the same, I contend that I don't think it is the same.
So you would suggest that a baseline has different directions of down along a straight flat line. Are you insane?
Along a straight flat line, if you assume a straight flat line, then they wouldn't.
What, like
but
with a
I'm not
triangle and that?
assuming
Would you say that when we're doing triangulation with flat baselines, we're not assuming straight lines? We're assuming different directions of down along straight flat baselines, are we? Are you insane? Second time.
No, trilateral.
So you appreciate then that straight flat baselines with 90 degrees at your position and 90 degrees at the ground position, potentially thousands of miles away of a star, is a flat Earth then, Matthew, third time. Not different directions of down along a straight flat baseline. That's the third time for that
Right.
one.
If you assume a flat Earth, then the baseline is flat.
So are we not assuming a flat Earth when we measure 90 degrees to the ground position? There's no assumption. It's 90 degrees, that's flat. No assumption needed.
If the direction of down is parallel, then if you make that assumption, then it would be
So
flat.
what assumption? It's a straight line with 90 degrees to you and 90 degrees at the base of the star. What assumption are you making? It has to be that. It has to be flat.
Your assumption of saying straight line.
My bad.
As soon as you say straight line.
And why would we suggest that between us and thousands of miles away at the ground position isn't flat?
By assuming the globe, then you would assume it's not.
Well, when we don't do that insanity, we can't use a globe, can we? Because we wouldn't have 90 degrees at the ground position of the star, would we?
That's right. You wouldn't. If you assume the globe, you don't have.
Fourth time, Matthew. Not possible on a globe, then. Definitely a flat Earth, then, Matthew. No assumptions, just factually measuring the ground position with a straight flat line. No assuming there's different downs along a straight line. But ultimately, we're not using different downs on a straight line that's got 90 at each end of it. So that's a fifth time. Flat Earth, then, Matthew. Ground positions, you're on the ground. Star position on the ground, 90 between the two, sixth time. That's a flat Earth then.
Of course, if you're doing it that way,
Stutter for me, Matthew. Of course, it is a flat Earth we will be measuring and navigating, correct?
if you're doing a triangle navigation like that, then
We are. So we are doing triangle navigation like that, so it is a flat Earth we are dealing with then, isn't it, Matthew? 7 attempts. 7 attempts, ladies and gentlemen. Bit of stuttering. If we're doing it like that, we are. So that's a flat Earth then, 8 times.
I concede that if you do a celestial navigation with 90-degree triangles, that the only way for that to work would be if the Earth is flat.
Welcome to Flat Earth from an educator. The only way to do triangulation, which is navigating the Earth, potentially saving your life, is to do it flat on a flat Earth. Thank you, Matthew. That's correct. Earth is measured and navigated flat.
Celestial navigation doesn't use triangles.
Triangulation doesn't use triangles? I'll ask you again. Why are you teaching children?
They're not children. They're most.
So why are you suggesting that triangulation doesn't use triangles, you stupid idiot?
I thought you were talking about triangles that.
What, triangulation triangles? Like in navigation that proves a flat Earth triangles? Yeah, we are.
The circle of equal altitude.
That would be a flat Earth. So an area that's a massive circle that's of equal elevation, definitely not curving away from you at 8 inches per mile squared. Is that what we're talking about just before we go further?
Right. You have.
So we are now going to be discussing areas of equal elevation used in navigation. That's flat Earth areas without drop like on a globe, just to be clear.
Right.
Right, so that would require a flat Earth then, Matthew, before we go forward talking about these areas of equal elevation. This is a flat Earth we will be discussing then. No drop.
Right, to do those kinds of calculations.
Just slower. That's right, Nathan. This will be a flat Earth I am now going to discuss because it's an area of equal elevation, not falling away at 8 inches per mile squared. This is a flat Earth then that you will be discussing with us. I just need a yes, that's correct. This is a flat Earth required situation. That's what I need.
Right. For that kind of calculations, you definitely need a flat Earth.
Well, we do those calculations, and we are navigating using these 90s, aren't we?
I don't think so, but...
You don't think celestial navigation uses flat baselines? You think that in celestial navigation, the ground baseline's falling away because there's different downs along the flat line with 90s on it? Again, I'll ask for the 4th time. Are you insane? Why are you teaching children?
Because I'm smart.
Sorry, you think triangulation doesn't have triangles in it, correct?
If you're talking about finding your...
just a no or a yes will do.
No.
No, there aren't triangles in triangulation. Or yes, there are. Which one is it?
Trilateralization, which was what...
Sorry, were we talking about trilateration or triangulation? Did you need a subject change there, Matthew? You seem to be a bit weaselly and a bit slippery. Again, I question why you should be teaching children. I've given you the question several times. I didn't ask about trilateration, did I?
No.
So, do you, as you have stated, this is now the 5th time I've asked you, believe, because you are insane, that triangulation doesn't have triangles a part of it?
Triangulation uses triangles.
So why in unholy hell did you declare otherwise and suggest that it wouldn't, or that we'd have different directions of down along a triangle? Why would you do such insanity?
Because when you do celestial navigation, assuming a globe, you do trilateralization and you don't use triangles.
Okay, when you do triangulation assuming a globe, how do you get a horizontal baseline from a curved adjacent?
You just can't. There's no such thing.
You just can't? Sorry, so when you say triangulation on a globe, you can't get a horizontal baseline. For the 90s you discussed earlier, on a globe, you can't do that on a globe, correct?
You can't. That's right. You can't.
That's right, you can't. So, again, we'd need a flat Earth for this then, wouldn't we, Matthew?
To do the calculations the way you're describing with using...
I'm not describing anything. This is celestial navigation. Don't try and pin this on me like it's a claim I'm making. This has saved people's lives, Matthew. It's not Nathan's celestial navigation. It's just celestial navigation. Thank you. So we'll need a flat Earth for it, though, won't we, Matthew? Because we can't do it. We can't get a baseline with the 90s you described from a curved adjacent. That would be a curved baseline. That would be a globe Earth. You said triangulation on a globe. I ask you where you get a baseline for the 90s you described. Answer, we can't. Conclusion. Try again, second time. We'd need a flat Earth then, wouldn't we, Matthew?
We would need a flat Earth to do triangulation for celestial navigation with...
Boom! Earth is flat. Many lives have been saved by triangulating positions with respect to the stars and their ground positions 90 degrees along a flat Earth to your position. So Earth is flat, as confirmed by Matthew Learns. That's
No,
how
I didn't confirm.
that is how it is navigated. It's like the guy yesterday who has to talk through the conclusion. You're not in charge here, Matthew, I am. That means shut up at the point that you confirm that we need a flat Earth to do this. I then summarise your conclusion that we will require a flat Earth for the 90s along the flat baseline to the ground position of the stars. Flat Earth required. Now, you're about to start talking about areas of equal elevation. Again, flat Earth required. What were you going to, pray tell, about areas of equal elevation, I wonder?
Yeah, so you can shoot a star and figure out from the charts how far away the ground position is. That's what you do to find out how far away you are from that ground position. And that doesn't require triangles. Just finding that
Sorry,
one
the ground
distance
position with
isn't
90 degrees along the line to you on the ground, that's not along a flat baseline anymore. Why would that be?
because I'm assuming a globe instead.
Right, so but for the fact that you are measuring 90 degrees that you've already confessed you couldn't do on a globe, you are still assuming a globe that doesn't work with this. Nurse, just cart him away and have him fired immediately, because in spite of the logical inconsistency of requiring 90 degrees to the ground position of a star, he's still saying that, oh no, I'm not doing it flat. You are factually doing it flat, Matthew, because I'm assuming a globe on top of the fact it's measured flat. Well, that makes you stupid and insane and not worthy of educating anybody. That's stupid, Matthew. If you're measuring it flat with 90 on the ground to your position, it factually isn't a sphere that you're assuming. Are you stupid?
No, I'm not stupid.
Why are you assuming something that is factually being measured flat, and you've affirmed that several times? Why would you assume you're doing it globe-shaped when you can't, and have confirmed that also?
No, so that's a good question.
You damn skippy it is. It's because you're insane. You can't do it on a globe, you stupid idiot.
Right.
Right! So why do you educate your children about how Earth is sphere-shaped when it's navigated flat?
There are two different ways to do celestial navigation.
No, there's only one. You require a flat baseline and 90 degrees to the stars. I asked you how you'd get 90 on a curved baseline, the adjacent being curved, and you said it wasn't possible. There aren't two ways of doing it, there's one. It starts with an angle off a baseline, 90 degree at your position and the star. That's a flat Earth. You have already confirmed this. That is how celestial navigation is done. Facts. Nobody assumes there's different directions of down along baselines unless they're medically insane, as you must be.
Yeah, my assumption that the Earth is...
We don't give a shit about your stupid, insane religious assumptions. It's measured flat, Matthew. Don't tell us about what you assume. We don't do that here. Didn't you get the memo? We don't beg the question on Flat Earth debate. Stop doing it. Just talk about what we actually measure. Not what you assume when you're taking 90s to ground positions on a flat Earth. Don't tell us about your assumptions. I'm not interested in your religion that you peddle to children. So it's measured flat then?
I feel like he's realising the Earth is flat, but he's having a hard time admitting it to himself.
Yeah. While he's trying to figure out why the hell he's telling me about how flat it's measured, but yet his assumption of a globe must take effect, I'm questioning his integrity as an educator and asking for his job as a result of this deceitful behaviour. No, you don't get to just assume your religious belief when you're peddling actual measurements. You'll get told off, and I'll appeal for your job to be taken away from you. That's what I will do when you tell me, after telling me how flat it's measured and how equal areas of elevation aren't curving away at 8 inches per mile squared, that you still assume it got a curve to it. Factually hasn't, and you know that. You're telling us that. You know how curved it can't be. You've told us that too, Matthew.
Yeah, I've conceded that the calculations you describe can only happen on a flat Earth.
Calculations, they're measurements, Matthew.
So the measurements is the angle.
Do you want to stop stuttering? Get a grip, man. Aren't you an educator? Do you stutter like this for your children that you say aren't children? The very impressionable youth that you lie to about Earth being a sphere? Stop stuttering and take a browbeating from a flat earther. No, Matthew, you've told us how flat it is. But yet you still insist on your religious faith being peddled in assumptions. Logical inconsistency much? Well, that's not a fallacy, that's a logical fallacy.
Assume
Right?
that the Earth is spherical. Assume the Earth is a globe. We can calculate a radius. Therefore, this proves Earth is a globe. No, that's a logical fallacy. That's not a fallacy. That's a logical fallacy. It is true that this observation is also consistent with a flat Earth. However, I'm not lying or using a logical fallacy, but Eratosthenes assumed that the Earth is spherical. That's not a fallacy. That's a logical fallacy. A begging the question fallacy. That's not a fallacy. That's a logical fallacy.
Well, that's not a fallacy, that's a logical fallacy, right, Matthew?
I haven't conceded that it's flat. I've said that it is.
It's measured flat. Then you tried to say it was calculated flat, and I corrected you when I said it was being measured. That's where we're at. Then you started stuttering. Notice how I can keep up with the conversation. So, it's measured flat, isn't it, Matthew?
No.
So when we measure with a sextant the degree, that's not measuring the degree. That's a calculation, is it, with the sextant?
Sextants measure degrees.
So they're measurements then, you stupid lying scum?
Sextants.
Measuring, yes, we know, you just told us. So we are, again, second attempt with a scumbag, measuring it flat then, aren't we, Matthew?
No,
So we're not measuring with a sextant. It's not a measurement, even though you've just confirmed it is a measurement. It's not a measurement again. It's a calculation.
Angles are measurements.
We calculate with sextants when we measure the flat Earth. Yeah, I'm just confirming that which you're denying twice after confirming that we do take measurements with sextants of a flat Earth. The one that you want to turn into a calculation and then talk through me while I correct you for the third time. This man's supposed to be an educator. He's getting a strip torn off him by me, a flat earther. Scum of the earth, lowest of the low, managing to tear a strip with total justification off a man who's supposed to be educating children. This is why he should be fired. I should not be able to get the better of this man as he tries to weasel in the word calculations for something he has confirmed are measurements. Measurements from sextants, Matthew. Measurements of a flat earth, Matthew.
You're right.
Why did you just try and lie twice then? Total scum. Total scum. Fire him. Contact his employer. Contact this man's education facility and tell them that's twice live to a live audience that he's lied. Yeah, it is a measurement then, you lying scum. Stop lying to people, Matthew. I don't like you. That's why you're getting shouted at. You're just a liar. Yeah, I know it's a measurement. That's why I had to correct you when you said calculation. Now you're conceding it for the second time. But you've told me no 3 times. No, it's not a measurement of a flat earth. Yeah, it is, Matthew. Yeah? Should be fired. Simple. Scum. Liar. Proven.
Honest.
Here.
You want a response?
I often get that from fundies who haven't got the slightest idea how to respond when I point out that they're a liar with examples live to an audience. 87 people watching. We need 1,000 people watching. This man, he's got 500,000 people that he gets to lie to.
Yeah, so...
Yes, so stop lying to my audience. When I say it's a measurement of a flat earth and you say no, and then we do this little do-si-do with you talking through me, when we get to the point that you concede it is actually a measurement, we'll move on when we get back on track. Yes, Nathan, it is a measurement of a flat earth.
Yes, Nathan, sextants measure angles. It is a measurement of an angle.
On a flat earth. Why are you such a weasel?
But why do you get to add "and" of a flat Earth?
Because we've got 90 degrees to the... Sorry, do you not understand 90 degrees to the ground position? Do you think the ground position means out in space off a ball position? Do you not understand English, Matthew? What do you think ground position means? Does it not mean that we're measuring the ground position?
It does.
So we're talking about the ground then, Matthew? Did the title of the show elude you? Did you forget where you are? Do you need to be medicated? Yes, we're talking about the flat Earth debate, Matthew. And we're very much measuring. Oh, do you need to talk through me, Matthew? Would it be better if I didn't rub this in your face, that we're measuring a flat Earth? Would it be better if you were talking while I'm highlighting it for the 4th time, something you've struggled to concede, that measurement that you just can't quite say is of a flat Earth? You couldn't quite say it, I had to say it for you. So we'll try again. That's right, Matthew. You described how it measures and what it measures. Ground positions and 90 degrees to your position. On the ground. So when we measure these angles with a sextant, try and stay with me, we are measuring a flat Earth, Matthew. 4th attempt with this one. Do you want to try and repeat it back? You're like that student that just can't quite get it and asks, why are you adding on a flat Earth when I've already detailed the 90 in the ground position? Do you want to try again, Matthew? Yes, we are measuring a flat Earth. I know it's hard.
Yes, you are measuring a flat Earth if you're doing a 90-degree flat baseline to the ground position. The only way that that would work is if the Earth is flat. Yes, you are measuring a flat Earth if you're doing a 90-degree flat baseline to the ground position. The only way that that would work is if the Earth is flat. And
oh my God. I just want people to note that there is a PayPal link in the info box below the video. There's a super chat. As much support as you want to offer me. That is a man who is a university grade educator. Yeah, notice your stature's being raised now. You've made absolutely explicitly clear that the Earth is flat and measured that way, Matthew. Yeah, now you're a university grade education rather than lies to children. Yes, thank you for confirming how Earth is measured flat, Matthew. We already knew. You, on the other hand, lie to children by omission when you don't tell them that Earth is measured flat with your sticks and shadows. You'll tell an audience of a shitty little channel that you've got on the side to pump out your lies on that it's measured flat and could also work that way. But by omission, you don't tell the kiddies that. You presumably don't tell them about the fact we require a flat Earth. You will interrupt me while I'm pointing this out, though. Very rude. Do you allow your students to interrupt you when you're in the middle of pointing out something they didn't understand after you've tried for 4 attempts for them to understand that Earth is measured flat, for them to finally parrot it back? You're just a bit slow, Matthew. 4 times I had to get you to do that. 4 times is not very acceptable, Matthew, for this very simple logical consistency about 90s and flat baselines with ground positions. But at the end of it, 4 times a charm, you're asking me why it would be the ground, making you stupid.
I don't think he's getting the elevation angle. He keeps saying angles, but the sextant, it's we've got to be precise. It's measuring an elevation angle. There's a difference.
Yeah.
No, you're right. Yeah, elevation angle. That's correct.
Right, and that would be in reference to the area of equal elevation, wouldn't it, Matthew?
Yeah, so the circle of
I just need a yes. Thank you, Matthew. You're not the
it.
one in charge of this discussion. We are. We know more than you. You keep getting things wrong and needing things repeated 4 times and having to be dragged backwards through bushes to concede things you've already conceded. Because it means you've got to confess Earth's flat to do this. Yes. Doesn't mean you need to be talking. You need to be listening, like your students. You are one currently. Our student. Now you understand, because we've taken you by the hand and explained, yes, Earth must be flat to do this. Now we're talking about the areas of equal elevation when you measure elevation angles. And we've already had the concession from you, Matthew. That would also be a flat Earth when we are talking about elevation angles for the Earth, ground positions, and areas of equal elevation. That's a flat Earth in every way, shape, and form, physically and fundamentally impossible if Earth was sphere-shaped.
Right. Doing that kind of calculation is fundamentally incompatible.
Measurement, Matthew, measurement. Measurement. Oh my God, he's that slow, slightly retarded student that after being corrected that it's measurements needs to say calculation. Slow, aren't you, Matthew? Do you want to
I'll say-
slowly repeat?
I'll
Don't
use
interrupt me, sunshine. Know who's being educated and who's dumb. That's you, dumb. Not calculations. You've had one deck tell you it's a measurement of an elevation angle with respect to the area of equal elevation that requires a flat earth and is fundamentally impossible if the ground is curving away. We've already had the concession once. We just need to hear it again, Matthew. You, the student, needs to affirm you understand. The elevation angle measurement, not calculation, is in reference to an area of equal elevation that fundamentally proves Earth is being measured flat. Do you want to just affirm that back to me like a good student of the flat Earth, Matthew? Go ahead.
Yeah, so the measurement, not calculation, the measurement of an elevation angle above a flat Earth assumes a flat Earth, and the area of equal elevation. Area is a calculation because area is a calculate. You're only getting a angle from a sextant.
Elevation angle.
He's done it again. He's
elevation
slow.
angle.
He
A
doesn't
sextant
quite
gives
get
you
the point.
elevation angle.
No, let me just speak to one deck. One deck, he's thick. So say it really slowly to him and then make him affirm it to you back. Because Matthew's slow. Why the hell this person's educating anybody is beyond me when we have to take multiple attempts to explain basic concepts like measurements versus calculations. No, we're still struggling to get you to understand that we're going to be measuring Earth flat with an elevation angle measurement. We're nearly there with you, Matthew. You're just a bit of a struggle. We'll have a word with your mummy. Tell her you're a bit of a pain in the arse. But in the meantime, we need you to understand this because you're holding the rest of the globe Earth back. Okay, Matthew?
Okay. So I concede that if you're doing triangulation to figure out your distance to the ground position, the measurement of an elevation angle with a flat baseline, 90 degrees to the GP, to the star, using 90 degrees at your position, that is only possible if the Earth is flat, the surface of the Earth is flat.
And is that done, as opposed to only possible? Is that done on Earth?
You can, using a sextant, you can measure an elevation
Not
angle.
can, is
Now, how
it
you
done?
interpret
No,
it-
not past tense.
Yes, it is.
You-
It is done.
I'll try again. Let's not get it while you're talking through me after changing it to past tense. Notice how sharp I am, Matthew. I noticed that you'd rephrased it to past tense. I'll rephrase my question. Is that done daily by people so they don't die if they get lost, Matthew? Like right now, it could be being potentially done this second by somebody and only possible on a flat Earth to do. Is that done on Earth now?
Yes.
So that's all I need. Thank
Measurement.
you, student. So a life-saving exercise in figuring out where the hell you are is done and can only be done to save these people's lives if Earth is flat.
Measurement of elevation angles are done every day by people doing celestial navigation. Yes.
On a flat Earth.
I mean, it also works on a sphere Earth.
So
if
how
don't
do you
use
get an
triangles.
elevation angle measurement from a curved adjacent?
You don't.
So you don't do this on a globe. They factually measure 90 to the ground position. Is there something wrong with your memory? Is it not like we just went through this 20 minutes ago? Did you forget that you've already told us it's not possible to get an elevation angle measurement from a curved adjacent? That would be a sphere Earth falling away from your position at 8 inches per mile squared would preclude this measurement. It's not
you
possible.
can't get.
I know it's not. Don't affirm while I'm telling you, the student, what is not possible on a globe. I know. Dumb student with his stupid loud mouth talking when he should be listening. Yes, Matthew, I know it's not possible on a globe. You keep seeming to infer that it is. No, we need 90 degrees to the ground position, and you can't get an elevation angle measurement from a curved adjacent. So no,
Right.
Matthew. It's just your religious belief in a globe getting the better of you over and over again, forcing you to beg that question, because that's not a fallacy, that's a logical fallacy. Right, Matthew? You've got to beg the question, haven't you? You assume Earth's a sphere when measuring it flat. Why? Well, because I can't get an elevation angle measurement from a curved baseline. But that wouldn't mean you would assume it's spherical then. When you're measuring it flat, there's no need to assume it's flat. You're measuring it flat. Oh, but it's just a calculation, you weasel. Earth's flat, Matthew. It's measured that way and navigated that way. The fact that it is measured and navigated flat saves lives daily, because this is done daily, and as you affirm, can only be done on a flat plane. Facts. Earth is flat.
I mean, Matthew's basically saying that he's telling us that you can acquire an elevation angle from a curved adjacent. That's what he's saying, but that's impossible.
He also mentioned something about knowing the height of the star in the very beginning.
Right. If you draw the triangle, you have to know how high the star is to figure out how far away you are from the GP.
From the what? From the GP? That's incorrect. You don't understand celestial navigation. You don't need the height of the star. That's incorrect.
If you look at 29 past
That
the hour,
is
what George posted,
incorrect. You do not need the height. You need the elevation angle measurement off a flat Earth. You will then minus that angle measurement off a flat Earth from 90 degrees, the 90 that precludes this being done on a sphere, and then times by 60 to give you your distance to the ground position along the ground. Not different downs along a flat... No. The ground position that is a flat Earth requirement is where you will get the
where
distance.
did you get 60?
Is that you, the student, interrupting the teacher again?
Yes.
No, you said you need the height, and I'm correcting you. Matthew, if I hear you interrupt again, you'll be sent to the headmaster. Shut up! You minus your elevation angle measurement, the second time I'm having to say it because of the belligerent child we have to deal with called Matthew Learns, who for some reason has been given the means to educate other people. How dare he? Anyway, now that the insolent, insubordinate little brat has shut up, I'll say it for a second time. We don't need the height as this stupid idiot has just blurted out in the middle of the class. Wrong, stupid boy. You take the angle off a flat Earth minus from 90 times by 60. That's what gives you the distance to the ground position. That is a calculation. And that calculation does not require the height of the star, you stupid, insolent idiot. Do you understand? I just need a yes.
Yes, that calculation
Good!
does not require
Now
the height of
sit
the
down and shut up, you stupid dick who has just told over 100 people that you need the height. No, you do not, you stupid liar.
That's where the 60 comes from.
Minus...
You said
Sorry,
times
you think
60.
the height of the star is 60 nautical miles? When you
No.
measure 1 degree of the star above the horizon, you think that when it reaches the horizon, you can still infer that the 60 comes from the height.
So you said times
Do you understand
60,
my
and you're
question,
correct.
stupid boy? When the star reaches the horizon, is it physically touching the horizon so that we can infer that we have actually got an actual height to give us this 60 you claim?
No, if it's...
So it's not an
touching the
actual...
horizon.
So it's not a height then? The star doesn't touch the horizon. It has
Right.
nothing to do with its height because the star's not ever going to touch the horizon. So how the hell can you infer height?
Trigonometry.
So are we doing that to find our position? Seems that Matthew's decided to take us on a little straw man journey of how we would calculate the height when we're not using it. We are not using the height of the star, nor are we navigating to the star. Why
I
would
thought
we
you
want
said
to
we were
do the
using
trig?
a right triangle.
Why would
We're
we
not-
want to do
we-
the trig for the height? What use is that?
Because we're using a right triangle.
And
Times 60
yet we're
is a
trying to
linear-
calculate the distance of the adjacent, though, aren't we?
Right.
So again, why do we need to calculate the height? We don't. We're calculating the distance of the adjacent. So we don't need to do this. This is a little straw man that you're trying to burn. We do not. This is the fourth time with some clever dick student that thinks he's being clever. No, clever dick, sit down and
Right, you
shut
said
up.
times 60.
Shut
That's a linear
up,
equation.
you stupid, insubordinate little brat. No. You think you can take us on a merry dance about how we could get the height, but we do not. We acquire the distance on the adjacent. That's not the height to find our position to navigate. Is it, Matthew?
You're right. It's the
Yes, I
adjacent.
know I'm right, you insubordinate little shit. I know you think you're being clever by talking about the height, but you're not. And you're not getting the better of anybody, and you're not clever. Notice how you trying to be clever by trying to infer we need height was shot down in flames, and then you had another strip torn off you. I think it's time you went and saw the headmaster, Matthew.
I think he needs to go and read a book on celestial navigation, because all he's
Yes.
demonstrating is that he has no idea what celestial navigation is, how it works, and he thinks he can just use his knowledge of trigonometry to equate it. He's talked about a second method. There isn't one. We watched your demonstration of how you've tried to put it together using basic geometry. It doesn't work, Matthew, and all you're doing right now, you're either trying to be clever, as Nathan alludes to, or you're demonstrating your total ignorance of the topic. And it'd probably be better if you went away and did a bit of reading on celestial navigation. Then we could have a conversation. But most of this is Nathan educating you, having to tell you the flaws in your understanding with regard to celestial navigation. It's a bit embarrassing, really. I thought you'd be better prepared.
I'm not embarrassed. I think I've been saying things well. So I'm not ashamed of what I've said so far.
You don't have to be
How
ashamed,
how
but
can
it
you
is
be saying
embarrassing
things well?
for you.
There's no, you can't, can you cite anywhere where they're concerned with the physical height of a star in celestial navigation? Anywhere?
Nowhere. Elijah's right. There's
So
absolutely
then,
zero.
if I'm right, how could you be speaking well when we're informing you of this and you keep on insisting that the opposite would give you the height of a star? If we're right, why do you keep insisting that?
He's got a religion.
Yeah, I don't think you're right. And showing that you would have to
Well,
have
isn't
the
that a
height.
contradiction? You just said, yeah, you're right.
So he's just going to do it
And
again.
Exactly.
Showing that you would have to have the height. You don't have to have the height. I've already educated him. He's just belligerent.
All he's got
Matthew,
is
Matthew,
double-speak, Colin.
Matthew,
That's all
did you
that's
not
happening.
understand me explaining that you don't need the height? You're going to now insist that you do.
I understood. Yeah, I understood what you were saying. You say you do this thing with the 6 times 60 nautical miles and to find the distance to the ground position.
That's not height.
Right. The height.
Right.
The height
Stop
is
talking.
the opposite.
Stop talking. That's right. It's not height. You've brought it up, and Adam has just said, yeah, either you're completely ignorant or you think you're being clever when you infer that height has something to do with it and it doesn't. So either you're ignorant or you're trying to be clever and you're not. You're not winning.
Yeah, you're talking about finding the adjacent, the distance to the ground position.
Yeah,
of the
we're
right
trying to
angle,
navigate.
correct?
Yeah, it's called celestial navigation, not celestial star charting.
Yeah, so the right triangle.
Yes, so we're
you're
only
finding
interested in
the adjacent.
navigating on the ground. So, yeah, when you talk about the height of the star, it pisses us off. Can you not tell? Because it's a straw man that you numpties who have a sphere belief who, quote, I'm just assuming it's a globe. Yeah, okay, numpty, we know you've got a religious belief that you must assume. But ultimately, we're measuring Earth and navigating Earth flat. What's that? We need the height of the... We're not doing that, though, are we, Matthew? And now we're here again with you affirming we're not doing that. But you keep bringing it up, thinking you're being clever. You're not. And it's annoying. Meanwhile, we've got precisely everything I need from you. You affirming Earth is measured and navigated flat. It's the only way it can be done.
Yes, you are measuring a flat Earth. If you're doing a 90-degree flat baseline to the ground position, the only way that would work is if the Earth is flat. And
If it wasn't, you wouldn't be getting adjacent because they'd be curved and they wouldn't be triangles. You wouldn't have 90s. Earth is required to be flat to navigate it. And you've affirmed it in every respect. But then it's, oh, but what about the height? Maybe I can win this straw. It's pathetic.
Right triangles have perfectly flat adjacent sides.
Sorry, you're asking me if a triangle has flat straight lines. Sorry, Matthew, I'll ask you a question in response. Do curved lines form angles for a triangle?
There are no curved lines in triangles.
So
right.
you just asked me if all triangles have flat baselines. Essentially, that's what you asked. So do you appreciate how irritating it is that you are in front of people educating them, when me, who is considered scum of the earth flat earther, is having to educate you on the fact that when you ask me if you can have a curve to a triangle, how utterly absurd it is that you've got a license to teach? Do you understand how I feel, or why I feel that should be stripped from you immediately? Given that you're asking
Yes.
lowest of the loaf, scum of the earth, flat earther, if a triangle can have a curved line to it.
I was saying it can't. I'm agreeing with you that triangles don't have curved lines.
But earth must be flat to use them for triangulation then.
Right.
Right. Yeah, earth must be flat.
Earth must be flat to
Yes, that's right, Matthew. Welcome to flat earth. Earth must be flat to save lives at sea when lost. We know. We prove earth is flat with this. You also prove earth is flat with this, Matthew. This will haunt you.
Well, I know
You have no idea what you have done here today, have you?
I know he's trying to be facetious, but again, when I asked you to cite where in celestial navigation they would be trying to obtain the height, you said yes, you're right, and then immediately after said I was wrong. So, seeing as that you're being facetious, again, I ask you, can you cite anywhere in celestial navigation where they're considering the actual physical height of the star, like you keep on suggesting?
So yeah, I apologize. I didn't mean to be facetious if you took it that way.
No,
So,
no need for
I
an
didn't mean to.
apology, but you obviously think that we've gone awry somewhere. So again, pertaining to the opposite, can you cite anywhere in celestial navigation where they're concerned with the height, the physical height of a star?
They are never concerned with the physical height of the star. You're
Why'd
right.
you keep bringing it up
Oh,
then?
okay.
The
Why'd you keep?
altitude
It's
of the
just
star.
so it's just a straw man then. We're debating about how Earth is proven flat with celestial navigation. You keep bringing up the height. You said we need the height. Now you've just affirmed it's not needed. It's not referenced. So, but you just keep bringing it up to burn the straw man, right?
I'm not trying to straw man you. I'm saying.
Sorry,
that,
it's not relevant to the subject. Sorry,
right.
Matthew. Do you understand what a straw man is?
I do.
Explain to us what a straw man is. We'll see whether or not this is one.
Falsely representing your opponent's position in order to knock it down easier.
So, when we're talking about celestial navigation, which specifically and affirmed by you has nothing to do with height, were you to bring up height, it would be a position we're not taking and has no relevance to our position, so you can knock it down.
Yeah, I'm not saying.
Yes!
That's your
Shut
argument.
up! Yes, that's right. Yes, it is in fact a straw man as I detailed then, Matthew. Yeah, you're really getting on my nerves, Matthew. I want you to off before I really lose my temper with you. Yes, you are burning a straw man, and when I ask why you're doing it, why you're burning the straw man, you start defending why you aren't. I actually hate you, Matthew. You're like the worst type of scummy teacher there is. Yeah? A weasel, a shyster, a scumbag. Now get out of my sight. Just leave before I really lose my temper with you. Please leave.
I think that's a very good idea. I've got no desire to speak to you, Matthew. You've come across the most disingenuous, snidey person. The way you've just agreed and disagreed and tried to set up what you thought was some kind of intellectual trap. It's pathetic. It shows the level of intellect you truly have. Yeah. And more importantly, it shows the type of person you are. I've got no desire to talk to you. And fundamentally, one bit of advice: go away, read a book on celestial navigation, because other than demonstrating your flaws in your character today, you've also demonstrated the flaws in your knowledge.
Mm-hmm. Yeah, I was
Good
gonna
morning,
say
everybody.
90 degrees. What's up, chocolate? 90 degrees
What up, bro?
off of a horizontal plane. You don't just have 90 you don't have 90 degrees without it, because it's 90 degrees of what?
Of a vertical to the ground. He invoked a flat plane, even when he said he didn't need it.
Mm-hmm.
To Matthew's
Didn't need
credit,
it
he
to
has
get
stuck
what? An
around, by the way.
elevation
Look,
angle?
guys, although I told him to bugger off, I have now calmed down, and he has stuck around. So, just so you know, if you do want to talk about it, you're not doing the horrible talk behind his back thing. He is still here, just so you know.
No, it's all
I
right.
want to
What's up,
ask him
Matt?
if I can. Like, does he have any feelings, or is he just really good at holding it back about the situation, or is he like, no, it's no issue whatsoever? I mean, you don't have to uphold that thing necessarily, right?
I give you guys permission to talk behind my back anytime. I don't mind. As far as my feelings go, because I think I'm right, it doesn't bother me too much if I encounter this kind of like.
How do you think you're right?
Neil,
Wait,
please.
Just let him
you
finish.
think you're right?
Neil.
Yeah, separate
Sorry,
question. That's
continue.
a different topic. I'm just saying because I'm fairly confident in what I believe. It doesn't bother me to encounter opposition to those ideas.
I told you he's under hypnosis.
Wow. So while in the middle of conceding all of Nathan's points, you still think you're right. You think that's somehow normal?
Can you justify that, as a matter of fact? Like, justify being wrong as far as the points are concerned, trying to straw man us with triangulation and being concerned with the physical height of a star. Seeing is that you agree that that's not what's being done in celestial navigation. And seeing is that, the angle is a right triangle formed by you, the GP, and the angular relationship to the star justifies saying that you're right.
Because I was trying to be careful to say that that kind of calculation that you described with the right triangle
No. That's not a calculation. It's a measurement. An angle is a measurement, not a calculation. So justify how you're correct.
You're right. Just the raw angle is a measurement. As soon as you put it in a triangle, then it becomes a calculation. And I was saying that kind of calculation is not possible on a globe.
Well, the
So
measurement is not possible on a globe.
Well, a measurement's just a measurement. It doesn't,
No,
using a
the measurement concerning the angle to a star and its GP has nothing to do with calculation at that point.
right.
And the thing is, if you have a GP that's curved away from you, you don't have 90 degrees.
Right. Yeah, sextants just measure angles, and that's it. You get a number. It's 50 degrees or something.
The elevation
Yeah,
angles.
So then why'd you bring it up then?
Elevation angles. Off the area of equal elevation that you're going to be measuring. It's an elevation
Here we go
angle.
again.
Elevation angle.
So justify being correct then.
So because I think you have to put calculations in there somewhere. At some point, you have to do a calculation.
Yeah. And the
So-
calculations.
justify being-
Okay. But those are done with respect to a flat baseline you established when you made the first measurement. And all of the measurements thereafter utilize that flat baseline that you measured when you measured an elevation angle.
So
Matthew,
once you
a
just
measurement
start
isn't a
describing a
measurement.
certain calculation, calculations require some kind of assumption about
this again.
the shape of the Earth.
Elevation angle measurement.
Yeah, it doesn't require the shape of the Earth. Can you justify that? Because flat's not a shape.
I
So
just give
if
you
you're just
guys
going to
the
get 50
definition of a-
degrees, you take out your sextant, you look at the star and say 50 degrees. Okay, good. As long as you do that,
50 degrees
that's
off
just
what?
a measurement.
No, that's two lines. What's the first line?
One line is from you to the star. One line is horizontal, which you could define as the horizon, or you could say 90 degrees from a plumb line, or however you want to define that.
Where we
So
started.
those two lines.
It's where we started. So that's a flat Earth.
At that point, you just have two lines and an angle between them.
Sorry, a baseline or the 90 degree at the bottom of it on the ground position. Yeah? To establish this ground position for navigation on the ground, we're navigating the ground. We're saving our lives on the ground. And we're doing a measurement and establishing first a horizontal baseline. That is a flat Earth measurement. We've already done this 3 times, Matthew.
You're right. That is a flat line that you're measuring the angle between two perfectly straight flat lines.
Yeah, for the ground position.
Matthew, may I ask, do you think the celestial sphere is held fixed and you rotate the flat plane?
No. I'm not 100% sure I understand your question, but like rotating the flat plane, I don't know anybody who thinks that's what's happening.
You rotate the angle from where you measure on the flat plane where it intersects your sphere, I guess you would have to say, before you would accept it. So the flat plane where it intersects your sphere, that's what's actually rotating, and the celestial sphere is held fixed, right?
Oh, I see what you're saying. Yes. Yeah.
Right, but in reality, we're just taking an angle to a star along a flat baseline. We're not transposing the angle we measure along a flat Earth, the flat Earth baseline, the measurement. We're not taking that to the centre of hell in the middle of a core of an Earth that's then surplus to requirements when you measure out from that flat plane equatorial in nature to the stars through a sphere Earth that's surplus to requirements. The sphere Earth is entirely redundant when you transpose the angle you measured off a flat Earth to hell.
So Nathan, I heard you watched through my response video recently. Was that how long ago was that?
3 days, 4 days, something like that.
I'll go through and watch it. So yeah, I appreciate you featuring that on the show again.
Why didn't you put it on your main channel?
My main channel is mainly people looking for prank videos and that type of stuff. So I try to like not put these complicated things on my main channel, but I am considering putting a version. Like also 20 minutes is really long. I mean, I know it's not long for your channel, but 20 minutes is long for my channel.
That's now
Sure. But in that video, you explain what a logical fallacy is really well, and then use the logical fallacy and say it isn't one immediately afterwards.
Oh, yeah. So, saying the Earth is a globe, therefore, we can measure a radius, and that proves the Earth is a globe. That's a logical fallacy. So you're right about that.
Yes. Then you said the same exact thing and said it wasn't a fallacy.
So, assuming the Earth is a globe and then using that to come up with a radius is not a fallacy because it's not a proof of a globe. Right? Eratosthenes wasn't proving the Earth was a globe.
That's the problem with the fallacy, Matthew. Is that when you're begging the question, the conclusion is based on the assumption. The premises have not been proven. That's the point.
So you understand.
That's why we're so against them.
So you understand that it is exactly as just stated, the same exact thing, but with you saying that's not a fallacy afterwards, even though it absolutely is. It assumes the premise and the outcome. So if the Earth is a sphere,
no, you're right.
If the Earth is a sphere, then I can measure the radius, and here's the radius of my sphere. That's a begging the question fallacy. Repeating it won't suddenly alter that.
You're right if you're going to say that the end statement is therefore Earth is a globe. If you're trying to prove the Earth is a globe, then that's circular reasoning. That's the begging the question fallacy. If you're saying something less than that, like if the Earth is a sphere, then here is what the radius would be. That's not proving the Earth is a globe. It's just saying what the radius would be.
Yes, that's correct. That's not proving that the Earth is a globe.
Right.
That's right. But you're still measuring it as one. Ergo, begging the question. I don't know if there's an invisible unicorn in front of me, but if I assume there is a physical, invisible unicorn in front of me, I can measure its bowel movements. Now, so long as I don't state that I'm implying there are physical unicorns, then it's perfectly acceptable for me to present the evidence of unicorn digestion. I just don't declare that I've assumed they're true. But the digestion
Now
in
you're
the imaginary
understanding-
unicorns, that's definitely worth presenting. The imaginary digestion in the imaginary beg the question of unicorns that I'm assuming are real when I measure their digestive tracts. Right? But that's not begging the question, according to you. Yes, Matthew, it absolutely is.
That's why you have to be careful about what you're stating as the conclusion.
Right.
If you state it as, if you like explicitly say, therefore I'm proving that the Earth is a sphere, then that is begging the question.
No, you don't have to conclude a begging the question fallacy for it to be a begging the question fallacy. That's incorrect. Clearly, you don't understand how fallacy works. Not stating the conclusion. The same is true for a form-based logical fallacy. You don't have to give if P then Q, Q therefore P for me to state that you are using a logical fallacy. I can conclude the fallacy for you.
And that conclusion is the part that would make it a fallacy. So
Yeah, Earth being
I
a
stop
sphere.
short of that conclusion.
Yeah, Earth being a sphere. If it's not a sphere, then the second statement about measuring radius of a sphere makes no sense, does it? But obviously, if you do assume Earth is a sphere, that's the begging the question fallacy bit, Matthew, then your conclusion will be that it's a sphere regardless, won't it, Matthew? So you don't have to state that conclusion because the conclusion is already assumed, even if it's not stated. The outcome's still the same, isn't it, Matthew? It's still begging the question even if you don't say it.
Yes.
Yes. So a large chunk of your video that you put out to a very limited audience declared that something wasn't a fallacy, then repeated the exact same thing and declared that it was.
So what would you call it then? Like if I want to say something about
a begging the question fallacy. Again, I'll try once more. I'll try once more. You asked, I'm telling you. Yeah. Saying a logical fallacy and then saying that's how a logical fallacy works. And then literally repeating the exact same thing, but not concluding with the thing that was assumed in the first instance is still a begging the question fallacy because you've assumed the outcome, regardless of whether or not it's stated. It's automatically the outcome because it was assumed in the first instance. That's how a begging the question fallacy works, assuming the outcome.
Do you have a suggestion of how to calculate the radius without begging the question? Like,
oh, what a beautiful question. No, Matthew. You see, that would be a very much you problem for a man with a religious sphere belief, for you to first prove that what you are actually doing is measuring a sphere. Now, given that we like these things going by on screen now, these triangles with flat baselines, these are from navigation manuals that show people how to measure and navigate Earth as flat. Not calculate it when they're measuring it, Matthew, just to be clear. Those measurements that were just on screen, they seem to infer that Earth isn't spherical in any way, shape or form, when you assume it is, and constantly suggests that you should be begging the question because you've declared what a begging the question fallacy is only to repeat it and say it isn't. And then come along and say, well, the reason I assume Earth's spherical when making angle measurements that could only be on a flat plane is because I assume Earth's spherical. But then when we're at the stage that you literally don't understand what a begging the question fallacy is because you think if you don't state the conclusion that's already been assumed doesn't make it a logical fallacy of begging the question when it does, we're struggling with you, Matthew. The comprehension isn't quite there with you yet.
So what about the things of the logical form, if X, then Y? Are those appropriate to say?
Sure, that sounds like science.
And what if X isn't true?
Then you would vary. Sorry, if X, then Y, you said.
Right.
Sorry, just stop. Matthew, if you're going to put logical consistency to me, it would help if you kept the order of the logical consistency consistent. Would you be willing to do that with me? If you say if X,
Yes,
then
yes.
Y, what if not X? You mean what if not Y? If X, then Y? Then Y. What if not then Y, you mean?
So that's a different question.
You just
I
need a
was
yes.
asking
No,
about-
no. If X, then Y. Correct? Yes, that's a suppositional statement. Yeah, I
Understand.
would state it if A, then B, when I describe the scientific method. This is a method that
Okay,
offers
sure.
empiricism,
A,
Matthew. So rather than assuming our outcome, what we can do is we can put this logical consistency, if A, then B, or if X, then Y, into a hypothesis. Now, that has another part to it. The contrapositive, the null. That's if X, not Y. They exist alongside each other in a scientific prediction. And the way you find out if one is true, that would be if X does cause Y, if X, then Y, is to vary X and see if Y happens. And if it doesn't, then your second statement, the null, zero difference result statement, if X, not Y, is automatically proven true. Ergo, the outcome is empirical. Only one can be true in those two logical statements, if X, then Y, or if X, not Y. Only one is true. Once you vary
Right.
X, you prove that Y is either going to happen or not going to happen. That's called science.
Yeah, that's a good explanation of that logical form.
Would you say that that is being done when you just assume Y?
No, you're
No, it isn't, is
you-
it? So there's no empiricism in you assuming this shit, is there, Matthew?
So yeah.
I just need a
in
yes
saying-
or
in
no.
calc-
I just need an affirmation. So there is no empiricism in your assumption of this shit. That would be globe
No.
Earth shit that you assume. There's no empiricism in that assumption, is there, Matthew?
There's no empiricism in that assumption.
That
That's right.
shit that you assume about a globe, there's no empiricism in that shit that you assume. Stop assuming that shit, Matthew. It's irritating. Yet we look for empiricism. It's a wonder that we're considered scum when we are educating people who are in universities educating others on what empiricism is. And he has to ask me about, well, what can I do if I can't beg the question that Earth's my religious belief? Not my problem, Matthew. Your religious problem that you need to overcome. Maybe you could tell us, given that you think you are on a sphere, how the hell you can measure it, given that all you ever do is assume it.
I don't think that can be directly measured at all.
So in spite of your faith in the globe, you now declare quite happily there's no way to measure it. I suggest, sir, that if Earth was curving away from me at 8 inches per mile squared, I'd be able to measure it and see it. It would be bloody obvious, because it would be falling away physically at 8 inches per mile squared, and it isn't. But you think, oh, I don't know how you'd do that. Well, you'd do it with some of the inferences that automatically assume are. They'd be true. They're just not. And when we do come to measure Earth, like on screen now, it's done flat, as you've affirmed. So when we actually measure Earth, so we don't die at sea, we measure it flat. When it comes to measuring a globe, university educator, oh, but I don't think we can even do it. No, you can't. It's measured flat, Matthew. Earth is flat. That's why it's measured flat and navigated flat and built on flat, and all the maps are flat and triangulation's flat and areas of equal elevation are flat. It's flat. That's how it's measured and dealt with and navigated. Not globe-shaped. That's just a non-empirical assumption you make.
Furthermore, I was at the beach a couple of days ago, standing right at the shore, looking across to Jersey beyond 6 miles, also looking at the shore. And I took that time to consider, well, if there was a geometric horizon, me laying down here, then it would be 1.2 miles. But as I looked out into the ocean and all of the boats and everything beyond 1.2 miles, the conclusion that I've heard some globers make just with argumentation is that everything beyond 1.2 miles is holographic in nature or not in the actual position. But when I look out there, it most definitely just looks like, no, I'm looking at things that are. That boat is where I'm looking at it at. I don't see anything at 1.2 miles or anything weird like a change from, physical reality to something that is in another position that I shouldn't see, but is it just it's very weird when you go to the beach and you try to consider some of the arguments that you guys have made, man. It's very weird. Not to mention seeing Jersey Shore from Coney Island in Brooklyn, beyond 6 miles away.
What'd I miss?
What is that?
Matthew, Matthew, that's what
Have you not been listening in?
You missed the funeral of Matthew Learns.
You mean the Confessions of Matthew Learns?
That can be my round out.
He's a flat earther now.
There you go, one deck. You can get the last word.
I'm just saying, I was just telling Curie, Matthew Learns is now a flat earther.
With that, I'm going to say, first and foremost, a huge, massive, enormous thank you to both Discord and you. We're still struggling to get you to understand that we're going to be measuring Earth flat with an elevation angle measurement. We're nearly there with you, Matthew. You're just a bit of a struggle. We'll have a word with your mummy. Tell her you're a bit of a pain in the arse. But in the meantime, we need you to understand this because you're holding the rest of the globe Earth back. Okay, Matthew?
Okay. So I concede that if you're doing triangulation to figure out your distance to the ground position, the measurement of an elevation angle with a flat baseline, 90 degrees to the GP, to the star, using 90 degrees at your position, that is only possible if the Earth is flat, the surface of the Earth is flat. That is only possible if the Earth is flat, the surface of the Earth is flat, the surface of the Earth is flat, the surface of the Earth is flat.